All right, so here we go. Let us now understand what is the difference between quantitative data versus qualitative data. Quantitative data means numbers. Any numerical representation, any numerical data would be called as quantitative data. And then qualitative data is categorical data. That means your continuous data and count data would be numerical in format, and categorical data would be non-numerical. It would be qualitative. A few days back, when we hired our HR person, the HR person, was saying that a specific resource was continuously coming late. He was logging in late. And then he told me, hey, what do I do? I newly joined as head of HR. If I implement HR process, the employee might get dissatisfied. And I told, okay, just check with him on why is he getting late. Supposedly the person told that I stay very far from the office. This very far was actually a qualitative statement. And then HR came to me and told that, okay, supposedly this guy stays very far from the office. I know how far he stays, by the way, the employee stays. So I told, my dear HR, whenever you get a qualitative response, ask them to quantify it. The moment you ask them to quantify, you will be in a better position to take a call. Then he went back, he asked him, hey, you told me you stay very far from office. How far do you stay? He told, I stay 800 meters away from office. 800 meters. That is less than a kilometer, right? So the moment you quantify with numbers, you really are going to get different insights altogether. So if someone is saying, I stay very far, then that's qualitative in nature. If you ask them to quantify, then they'll tell you probably they stay, a quarter mile away. Probably. All right. Next. I also have an example. If you ask someone to put their finger in a hot bowl, they might touch it and say, it's very hot. They might say it's very hot. But for someone else, they might say it's hot. For someone else, they might say it's warm. So it's going to be very subjective. This subjective value is nothing but qualitative. You're just saying it's hot or very hot or warm. Okay. But then if you put a thermometer within that, hot water or hot bowl, if you put a thermometer and then try to measure the temperature, you'll come to know the exact number. Is it, 60 degrees Celsius or 70 degrees Celsius or whatever? You get to know that. And that is quantitative in nature. Quantitative means you quantify the value. Qualitative means you just say very hot, and stuff of that kind. Then we also need to talk about the difference between structured data versus unstructured data, as well as semi-structured data. I'm just waiting for that to go away. It's super fast. I think I could nail it. So let me go here. Structured data is that data which can be represented in a nice tabular format. It could be a simple Excel file or CSV file or any tabular file. If you can arrange the data in a nice structured format in rows and columns, then that's called as structured data. Structured data is that data which can be arranged in rows and columns in its raw state. And what is unstructured data? Unstructured data is that data which in its raw format, raw state, cannot be arranged in rows and columns. For example, we have videos, images, audio files, some kind of textual data. All these are unstructured data types. That means this data in its raw format cannot be arranged in a tabular format. Now, if you look at videos, for example, videos are collection of multiple images which are taken at a rapid pace. Video is collection of multiple images. And how many images you can capture per second would be called as frames per second. If you can capture more frames per second, then you will get a high definition video. So within a video, you'll have multiple images. Let me take one image frame as an example here. But before we proceed further, let me show you something interesting here. Maybe you would have seen this long back, right? So if you were to look at it, this is a movie reel. If you observe here, each of this is a frame of image. Each one of this is a frame. Okay, and if you look at all these frames at a rapid pace, it would appear as if it is a movie. Let me go to YouTube and then let me show you Flipbook. Hopefully, yep, look at that. This part, it's appearing as if it's a movie. And let me see if I can show something else. Yeah, look at that. This is appearing like a movie, as if someone is going into the planet or you know, something on those lines. Look at that. This appears like a movie, right? Each of that would be frame of image. Okay. Now, when you take each image out, each image is made up of multiple pixels. Okay, each image is made up of pixels. And each pixel value ranges from 0 to 255, wherein 0 means black color and 255 means white color. Even if you have color images, when you try to analyze a color image, you are going to segregate the red channel, green channel, and the blue channel, RGB. Red channel, green channel, and blue channel, you try to segregate. And when you segregate those channels, you get black and white images. Each channel is a black and white image. And you have audio files, and then you have textual files, the movie reviews, or the product reviews on Amazon, or the social media comments, Twitter tweets. All of these are textual in format. Textual data, right? That is also unstructured. The data in its unstructured format cannot be placed in rows and columns. However, you can always transform the data. What you can do is, you can probably say that, okay, you're going to create a table. And if you have 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay, if you have an image which is going to have 5 rows and 6 columns, 5 multiplied by 6 would be 30. So you'll have x1, x2, x3, x4, x5. In that way, you'll have until x30. And say this is the first image, you take that, and you put each and every pixel value in that location. Maybe the first pixel value is 0, black. Second pixel value probably is 10. Third pixel value is probably 250. The fourth pixel value is probably 113. So whatever be the values, this, keep entering. Then go to this pixel value, enter there. Go to this pixel value, enter here. Go to this pixel value, enter here. So on and so forth. So the moment you break down video into an image into pixels, you can take the pixel intensity values. And pixel intensity values range from 0 to 250. You take those values and place it in a nice tabular format like this. And then this becomes a structured data set. So unstructured data is that data which cannot be put in a tabular format in its raw state. However, if you transform the data, that means take a video, split that into multiple frames, take each frame of image, split that into pixels, and take each pixel value, put that into a table. When you do that transformation, the data would be, considered as structured data. Okay, so this is one part of the story. Then this tabular data is also called as columnar data. Tabular data is also called as columnar data set. These are different terms. As I've told you, in the initial days, all you need to focus upon is terminologies, the lingo. Okay, next. We also have something called as semi-structured data. Let me show you semi-structured data by probably taking an example of the file that we have here. Okay, I found this. Let me show you that. Okay. So this is an HTML page, hypertext markup language, a programming language which is used to build websites. If I were to right click on this and go to view page source, you would see certain tags. Okay, so tag, T-A-G, tags, right? So here you have title. You might say that, let me come up with a column called title, and whatever is mentioned within the title tags, I would take that and input here, a sample HTML page. And whatever exists in between address, for instance, Probably you'll take that and mention that as address. And within address, you'll mention this complete address. Then probably you'll go to table. And within table, you see something called as name. And you'll probably take all these names and then put them here underneath. You'll probably take qualification and you'll put all the qualification details, one below another. The point that I'm trying to drive is, while HTML file is also unstructured, in order to convert this unstructured data into a structured format, that is into a tabular format, it is slightly easier than converting your unstructured data like videos, images, etc. If you want to convert that into structured format, it might be difficult and it might be time consuming. However, if you have semi-supervised semi-structured data, converting that into a structured format is far easier. It's far simpler. Okay, so that's the difference, friends. So if you have unstructured data, and if you want to make it structured, it would be difficult and time consuming. However, if you have semi-structured data, and if you want to make it structured, semi-structured data examples could be HTML file or an XML file, or you have something called as JSON, Java. And if you want to do this, it would be slightly easy, or I would say relatively easy. Why am I using the term relatively easy? Because in comparison to converting unstructured data into structured, converting semi-structured to structured would be easier and faster. Okay, this is one thing that you need to understand. And you name a company, you would understand that they would be dealing with videos. If you take, for instance, any company, basically, at a bare minimum, they should be having CCTVs, which will capture the videos. And you need to do video analytics to understand, is there an intruder who has entered your premise, for automatic attendance tracking of your employees, etc. When you say video analytics, it is nothing but image processing, because videos are combination of multiple images. So when we say video analytics, you're in some sense talking about image processing only. Okay. You name a company, aviation, for instance, will have video sensors, will have audio sensors. When, pilot and the navigator, when they discuss and talk by sitting in the cockpit, all the conversations get recorded, but all the conversations go into black box. In every flight, in every plane, rather, there'll be a black box. During, uncanny scenarios, or when the flight crashes, etc., they take the black box and then they try to listen to the audio conversations. Textual data, for example, you take Amazon or any of the e-commerce portals, people leave reviews. Analyzing the reviews or analyzing the social media content would be analyzing unstructured data. And today, every company has social media presence, and customers resort to social media to provide feedback. You are expected to analyze and review this. So this unstructured data is something which is available throughout. All the industries are, working on unstructured data, semi-structured data, as well as structured data. So you have structured data. I would call this as structured data. Example. This would be unstructured example. And then you have semi-structured data. And this is the example pertaining to that. Okay. And now we have big data versus non-big data. If you have huge volume of data, which is getting recorded at a rapid speed, and if you have variety of data being captured, that data would be called as big data. For example, if I just go here and say that we have something called as Pratt and Whitney, okay, this is a company which produces wind turbines, etc., and engines which are fitted into the planes, airplanes, aircrafts. And supposedly, a 12-hour flight journey can produce up to 844 terabytes of data from one engine of Pratt and Whitney. One engine, one turbofan engine would generate in 12-hour flight journey would generate 844 terabytes of data. How many flights would be flying in a given day? Just imagine the amount of data that gets generated. 844 terabytes of data. So the volume of data from a single flight, which is 844 terabytes of data, one single flight, one 12-hour journey. We cannot store that on any of our laptops or computers that we have. And think about all the aircrafts put together generating the data, all the turbofan engines generating data. That would be overwhelming, right? So that's huge volume of data. Velocity, speed. Continuously, the turbine would be getting generated. I mean, it would be rotating at a super fast speed, and it would be generating data continuously at a rapid speed. That's velocity. And you also have variety of data, because what happens is it's not just data from the engines, data from the sensors. You'll also have video cameras fitted into the aircraft. So video is getting captured. The audio conversations of the pilots who are seated in the cockpit, their conversations are continuously recorded. Continuously, they will be interacting with the air traffic controllers. Okay. So what will happen is if you're, say, taking off your flight from New York to probably Delhi, then throughout this, you would be assigned, your flight would be assigned a tunnel. Okay. Within that tunnel, your flight travels, and throughout probably somewhere, the air traffic controller of New York would pass on the control to another air traffic controller, and that air traffic controller would pass on to probably another air traffic controller in Dubai, from there to probably India, in that way, right? So throughout the conversations keep on happening, and then your audio, is captured. And there'll be a lot of sensors which will capture the air pressure, air wind, so on and so forth. So continuously, you are getting data from wide variety of sources. And if you have these three V's in your data, that is called as big data. A few books also include 4 V's or 5 V's, such as veracity. Veracity means uncertainty in the data, or some other V. You can keep on adding multiple V's out there, and that would be called as big data. Any data which doesn't have these characteristics would be called as non-big data. However, I believe this kind of explanation is very bookish. We want some practical explanation. So if you have, say, 2 terabyte storage in your infrastructure, in your server, in your computer, say you have 2 terabytes of data, and if you get 10 terabytes of data, for your storage, for your infrastructure, this 10 terabytes of data which is provided to you would be big data for your infrastructure, because you do not have the storage capacity. This 10 terabytes of data would be called as big data. Another thing is processing. I'm sure you all would have worked on spreadsheets, Excel files, but do an experiment when you find time on latest of your computers. Try opening 500 MB Excel sheet and try to create something, some bar chart. Try to generate a bar chart from your data. This is sufficient for your application to crash. If we show you one symbol, it will go on and on, round, run, round and round, which means you have to wait and wait and wait. You can go have a cup of coffee and come, or you can probably go watch a movie and come back. By then, most probably, you would see a bar chart, or maybe you see a message saying that your application crashed. So even a 500 MB Excel file, if you cannot process that, if you cannot generate the bar chart, then you just run into big data problem. So big data is that data which cannot be stored on your infrastructure, which cannot be processed using your applications. Okay, this is a more practical understanding of what big data is. All right. Why did we talk about these? All right, we discussed about these for a couple of reasons. One is, if you have big data, whether it is structured or unstructured or semi-structured, doesn't matter. Whether it is structured or unstructured or semi-structured, doesn't matter. At the end of the day, you end up implementing the storage and processing using Hadoop framework. There's something called as Hadoop framework. Okay. And if you have data which is not big data, but if it is structured, not big data which is structured, right? You usually end up storing that data in a relational database management system, such as SQL, or you have an open source database called as MySQL. We also have Microsoft SQL, Oracle database, so on and so forth. And if you have non-big data, which is either unstructured or semi-structured, then you store the data in NoSQL databases, such as MongoDB, Cassandra, etc. The reason why I'm introducing you all to these is just for you all to have a high level understanding. Mostly people won't ask you questions on, okay, explain me about Cassandra, explain me about MongoDB, etc. But it is always good to have a high level understanding of where the data gets stored, given that it's big data or non-big data or structured or unstructured or semi-structured. All right. So let me do a quick recap, and then we will move to the next set of discussions after that. I would be frequently using mind map because I want to do sufficient number of recaps. So friends, we are talking about CRISP MLQ, which is cross-industry standard process for machine learning with quality assurance, in which we have 6 phases. Within phase 1, you have again 2 stages. One is business understanding. As part of this, you record your business objectives, you record your constraints, okay, and also you list down your success criteria, business, machine learning, and economic success criteria. You list down your objectives and constraints using 2 to 3 words. And it is always recommended to use the terms such as minimize or maximize. And then you have project charter, which is a document, first document, which gets created on any project. And it would contain the details at a very high level. Once you understand the business problem, you need to collect the data which is needed to solve your business problem. So in order to understand what data do we need to collect, we have already discussed about the data types such as continuous data, discrete data. Within discrete, we have categorical data and count data. And then within categorical, you have binary and multiple. Within multiple, we have nominal and ordinal. And within continuous data, you have interval data and ratio data. Nominal data is the least preferred and ratio data is the most preferred. Okay, and then we discussed about qualitative and quantitative data. Qualitative data is categorical data. Continuous data and count data are quantitative in nature. And then you have structured, semi-structured, and unstructured data types. And we have discussed about big data versus non-big data. Okay. So in the next session, we shall talk about the various other data types, such as cross-sectional time series, longitudinal panel, balanced, imbalanced, offline batch data versus live streaming data, data collection techniques, so on and so forth. Right? We'll first have a high-level overview. Once we are done with understanding the high-level overview, we would be getting into each and every algorithm, and we will be trying to understand the finer nuances of the techniques. Okay. All right then.